It is my great pleasure to introduce Professor Zhang Yi to you as the keynote speaker for this session. Professor Zhang Yi is a tenured professor of the National School of Development at Peking University, as the chief scientist of recent Institute for Advanced Study of Peking University. He is also a tenured professor at the Center for Study of Aging and Human Development and Geriatric Division of School of Medicine, and director of the Center for Chinese Population and Social Economic Studies at Duke University. He is the member of the World Academy of Sciences, TWAS, for the advancement of science in developing countries. And he is also a foreign member of the Royal Netherlands Academy of Arts and Sciences. He is a distinguished research scholar of the Max Planck Institute for Demographic Research in Germany. Up to March of this year, he has published 179 English articles and 167 academic articles in Chinese. He has published 30 academic books, including 10 books written in English, published by well-known press in the United States and Europe. He has been rated as one of the highly cited Chinese scholars, and he was one of the authors of high-impact papers worldwide, rated by ISI. Professor Zeng Yi has received multiple international and national academic prizes. The major ones include the Dorothy Thomas Prize of the Population Association of America, the Harold Lassell Prize in Policy Science, and then the 2011 paper of Year Award for the American Journal of Public Health. He also obtained a national prize for advancement of science and technology offered by the Chinese government. In particularly, we would like to send our sincere congratulations to Professor Zeng Yi in this year, because the largest population association in the world, International Union for the Scientific Study of Population, IUSSP, just recently select Professor Zeng Yi to be the 2021 laureate for his great contribution to the advancement of demography and population research. He is really the very first Asian scholar to gain this great award. Without further ado, I would like to open the talk for Professor Zeng Yi. And because Professor Zeng Yi's health is not well, so to this talk, we will not ask Professor Zeng Yi to give a full-time speech. And Professor Wang Zhenglian and me will take part of his duty. Now, Professor Zeng Yi.
Hello, thank you, Professor Feng Qiushi. Ladies and gentlemen, so the topic of our presentation today is computational social science innovative methods of full household and behavioral algebra projections. Our presentation will consist of two parts. The first part is methodology and the data issues, which will be presented by Dr. Wang Zhenglian. The second part is illustrative applications of forecasts of households living arrangements, elderly, disability, undercare needs, costs, housing, and home-based energy demands. This one will be presented by Professor Feng Qiushi, who is an expert in this field. Thank you very much.
Hello, everyone, and this is Wang Zhenglian. It's my pleasure to, on behalf of Professor Zeng, to present our programming model. So there's 3 types of method of household projection. One is headship rate. The other one is macro simulation and then macro simulation. For the headship rate, I will talk about a little bit later. The macro simulation can handle large space with many covariance. And the relation of individuals can be explicitly returned, and it can provide rich output, including stochastic distribution and confidence intervals of outcome. Of course, it is very powerful in detailed analysis of complex behavior patterns and kinship simulations. There are 3 kinds of random variations here for macro simulation. One is amount of color random variations, and the sampling errors for the starting year projections, and also for the rhythm specification randomness. For the macro simulation, there's a limited in number of covariance, and it's called complex relations among individuals, not as detailed as macro simulation. But it is not limited to the sample size. It can fully use sensors information as starting point to project households of entire population. It's easy to use with user-friendly software. However, some macro household projection models rely on the data on transition probabilities among different household types, which are not available from conventional data sources, such as survey sensors and virtual statistics, and not closely linked to demographic rates. So that it needs to develop a macro model that requires only conventional data. So that is what a programming model does. Of course, programming model is more complicated than the headship rate. So we summarize this programming model as 5 core ideas. The core idea 1, it is a multi-state counting model. And unlike other macro simulation models, which use the households as basic unit, and it requires the non-conventional data on transition probabilities among household type status. And our programming model, we use individual as the basic unit of analysis, and thus only conventional available demographic data are required on programming model, and we forecast households and the population age 6 distributions simultaneously. So as we said, this model is a cohort component model, is extended cohort component model, so that in addition of population projection, we need age 6. So for the performing model, you only need to add another 3 important variables, which is marital status, co-resident with parents, and co-resident with children. So add more 3 variables, you can do not only population projection and also household projection. And for these 5 major variables, you can add other optional like race if you want to consider the households among different race. You can also add the residence like rural urban. For example, in China, we cannot rule out rural urban difference. Here show you the model how to deal with the marital status transitions. And in our model, we allow us user to define whether you're considering cohabitation or not. So if you consider cohabitation, it's 7 marital status model. If not, it's 4 marital status, only consider forced marriage, divorce, widowed, and so on. So another criteria is with needed individual status identified, we won't have huge cross status tabulations matrix if adopting conventional computation strategy, like US case, for example, if we have the 7 marital status, 3 status of co-resident with children and parents, and 6 parity and even with the children, and we won't have the huge matrix, and with more than 194,000 elements at each age of each sex for each race. It won't require huge data sets. It is not practical. Thus, we adopt an innovative computation strategy, which was originally proposed by Bankers in 1987 and further justified mathematically and numerically by Professor Zeng in 1991. And his figure show you how the accounting strategy in a model. Actually, we calculate the births separately to 2 parts. First half year of birth and the second half year birth. And we assume the change in the marital status union, co-residence with parents and children, migration and survival status occur in the middle of an interval. That's X plus XL plus 1. Also, we need to deal with statistics assumptions. And the reality is that the real world mostly allows assumptions of statistic independent. And we have to face there's a limited data source for the application of an independence assumption. In performing extension cohort model, we assume marital union status transition depends on age, sex, and race, but independent of other status. The fertility depends on age, race, parity, and marital status, but independent on other status. The mortality depends on age, sex, race, and marital status, but independent of other status. And as our model is very complicated, and we have to deal with the consistency between the sex and the children living home, number of children living home, or number of parents, and have the children left. So we use hierarchic mean approach satisfies most of the theoretical requirements and practical considerations. So we use this and to make sure and the 2-6 consequence and the married female and the males is equal, and so on. The last core idea is that in order to redo the subnational projection, and we use national standard schedules and summary parameters at the subnational level to specify projected demographic rates of the subnational region in future years. This is similar to the widely practiced application of model life tables and Barre's logical relation life models, and so on. Now we can compare with profiling model with headship rate. It's clear the headship rate cannot link to demographic rates, and it is impossible to incorporate demographic assumptions of fertility, mortality, marriage, uniformation, and deformation, etc. Our profit model, we use demographic rates from conventional source as input and closely link project households with demographic rates and summary measures on marriage uniformation and dissolution, fertility, and mortality, etc. And this figure shows you the major difference of strategy. Barre's model, we use the cohort approach and demographic rates as the input. And headship rate, they just do the cross-sectional calculation and without link with demographic rates. And now we look at the output, and the headship rate only can have 5 types output, and there's no household size available. And this is the Census Bureau publication in 1996 for US household projection. So we can see there's a very limited household type, and there's no household size available. Okay, here we can show you how many household types profiling model can produce. In total, we can have 40 types of household and categorized by different generations. And under each generation, you can based on reference persons, marital status, and the coincidence with children and parents, and the household size, and you have so many detailed household type. For example, for one person only, you can know in your study there are how many one male lonely, one person only household, how many women lonely, and what is the marital status they are, whether they are divorced or widowed, and so on. So let me introduce you about what kind of data we need if you want to run profiling model. So as we said, the data only from conventional data. So for starting point, the data you need is from the census. You can from the macro data to get the 6 age, race, marital status, the relationship to the householder, and whether they're living in the private and institutional household. This is from the macro data. And you also, because macro data normally is sample data. For example, US application, we use 5% macro data. So that you also need to provide 100% census public cross tabulations to ensure your study is entire population. That is first part of starting point population. The second part, we need the model standard schedule to know how the future demographic rates are. So you need to have the mortality rates, the marital status and unit transition rates, and the fertility and children leaving home and the migration. For the US application, and we got the marital status transition and fertility from pooled demographic survey data. And for the leaving home and migration, we estimate from census macro data. And the third part of the data is needed for the model is summary measures. And the summary measures is let you to tell the model how high or how low is future mortality and fertility and migration level. So that you need to, for the mortality, you need to give us future life expectancies at birth, and the fertility, you need to tell us the future total fertility rates and migration, and you need to give us, for the US application, we ask for total numbers. And recently, we further improved the model. And for migration, you can provide the general in-migrants and out-migrants and by gender, race, or rural or urban. So in summary, performing model performing extended cohort compounding model does substantially better than the still widely used classic headship race method in household projections. In addition to the academic research, performing method software can be used for home-based consumption and the service needs cost projections. For example, performing method software was employed for the US household energy projections and home-based vehicles by Professor Feng Qiushi and others. Now I want to show you how the model works. We did validation for the US data, and we use US census data in 1990, and also the demographic rates before 1990 as well. And we do the household and population projection, and based on 1990 census data, and we project the population and the households in 2000. And then we compare the performing output with 2000 census opposition. And here is the result. And we can see that it's very close, the total household and every household size. And here is the comparison between the population index is also very close. Okay, I think I'm stopped here and Professor Feng will do the second part.
Thank you, Professor Wang. And again, I seek your understanding that due to Professor Zeng Yi's health, please allow me to present on behalf of him. And it is also my great honor to speak on behalf of him as my long-term advisor. And let me just simply summarize what Professor Wang and Professor Zeng Yi has been talking about. They have summarized the major intention and background of Perfemi. And this is a very super important innovation in computational demography. And Professor Wang has introduced the 5 key computational core ideas about how we could model such a complicated phenomena of household. And in this whole procedure, you can see a lot of innovative ideas of computation, like how to simplify the procedure to make projection possible. And immediately, Professor Wang also talked about validation. Because for those of you who are not familiar with the mathematical part of this model, but simply want to use it for policy reasons, a more important thing is how accurate this method could be. And that's why the Profemi team has been doing a lot of validation to show Profemi is an accurate tool in household projection. Professor Wang just mentioned about the one of the big validation using American data, and recently the team also did validation for the subnational level. Professor Zeng and Professor Zhenglian and the team published a paper in Demography and did the 2 sets of validation tests. They are using the data from 1990, which is the historical demographic data, to project the household in the year of 2000. In this way, the team actually pretend we know nothing about the year of 2000. And then we could compare our projected outcomes with the real observation in the year of 2000. And by comparing the projected outcome with the 2010 census observations, we could see how accurate Profemi could be. We actually used the 2 strategies. One strategy is we simply just use 1990 census data as the baseline and use the summary measure before 1991. Assuming we know nothing, no information is available in the 1990s. Just use the information before 1991 to project the 2000 situation. And another strategy is we are using 1990 as the baseline, but we take advantage of all the available informations in the entire 1990s, which is very possible for many policy agencies, and then compare the result with the target year of 2000. And here you can see the outcome. You can see the left pie is a comparison. We are using the data totally before 1991. APE is the average percentage, absolute percentage error. Namely, we project the projection and the real observation are compared to see the difference in the percentage in the absolute terms. As you can see, if we do not use the information from the entire 1990s, we still get quite good, quite small error. And 30%, the error is less than 1%. About another 30%, the error is 1% to 3%. And about lower than 20%, the error is as large as about 5% or over. But more practically, if we further use information in the entire 1990, which is always the case for the real projections, we can see the error are significantly reduced, and about half of the comparison, get error less than 1%, and then very rarely we get error larger than 5% or over. And these are the validations with regard to the household result. And this is the projection error using the same logic, but we apply this to population numbers. As you can see, the pattern are very similar. And in conclusion, the projection errors are actually quite small. And for this, we actually not only check about household, but the total number of household, but we develop this validation in regard to the 1-person household, the 2 or 3-person household, the household size, and the 4+ person household, the couple household. so that we go to the specific household sizes to see under those specific categories, what is the performance of Profemi in the application to the subnational level of the United States. As you can see, the results are super good. You know, most of the errors are actually less than 1%. And we don't have, you know, very large errors. I mean, the maximum will be about 4%. And this is another round of tests. We are not only test the household, we go to the population structures. As you can see, we test whether our projection result will match with the population size, the percentage of children, percentage of old people, oldest old people, which means those who are aged over the year of 80. Also the dependent ratio of children and dependent ratio of older adults. Again, you can see the projection error in terms of the mean absolute percent error, the mean algebraic percent error, and then the median absolute percent errors. They are all quite small. They are all quite small. And we further apply this to some of the applications. If we use projection of Profemi method and use it to project the housing in the United States. And traditionally, without the help of the Profemi method, and people tend to use the traditional method called the hardship rate method. And this method have a lot of limitations, as Professor Zeng has discussed. Using this method, and we also use Profemi method. We compare these methods to project the housing in the United States in terms of number of 0 or 1 bedroom housing unit, 2 bedroom housing unit, 3 bedroom, and 4 bedroom. As you can see, these are very important information for energy consumption projection, for housing real estate market, even for the vehicle market. They have a lot of policy implications. They are the foundational parameter for us to understand market and policy plannings. But using the different method, we have again different result. As you can see, the hardship rate method obtained a very large error, as large as you can see 18%. In comparison, Profemi's error are much less. And methodologically, this is because, as Professor Zhang Yi argued, Profemi method incorporates the household size in the modeling, and therefore we could obtain much more accurate and reliable projection result, in contrast to the routinely used hardship rate. And that's why I think that this is very important research method, because if we rely on the traditional method in the social economic plannings, and the projection will make huge errors. As you can see from this table, the major error will happen in the small household size, like the 0 to 1 bedroom. And that's the limitation of the traditional hardship rate method. And we also further validate the method in the context of China. And this is also a subnational level validation. And we compare the real observation in the 2010 census. But we pretend we don't know nothing about 2010. We use the year of 2000 as the baseline, and with the help of Profemi, we can project the year of 2010. And thus, we could compare the real observation and the projected outcomes. As you can see, Profemi has excellent performance in projecting the population size, the collective population, number of households, and average household size. And then the difference between the projections and the real outcome, the real observations, as small as like around 1%. So Profemi is very accurate in this sense. And also we could go deeper into specific subcategories to see whether Profemi can project accurately in the general population and household. How about by different age groups? And this is the validation test by different age groups. As you can see, the projection error is actually also reasonably small. So in conclusion, the Profemi team led by Professor Zhang Yi and Professor Wang has made substantial progress in validating this research method. But still, in replacing the long criticized method of headship rate, people may ask, is it worse to use Profemi because Profemi is more data demanding? Is it worth it? I mean, yes, we get better, more accurate result, but also we invest more in getting the data. I mean, in comparison with the cost and benefits, is it really worth to use Profemi? And to answer this question, we would like to give you an example to persuade you that using Profemi is not only worthwhile, but also is necessary. So again, we project from 1990 to 2000 housing demands by number of bedroom for each of the 50 states plus Washington, D.C. in the United States. And we compare the headship rate and Profemi. You can see again that the headship rate model will get substantial projection errors as we show. Why this is the case? The census data show as compared to 1990, the 1 bedroom, 2 bedroom until the 6+ person household in 2000 in the United States increased 20%, 17%, 9%, 9%, and 15% respectively. And that means the American household is experiencing a very rapid transformation with the super large and super small household both increase substantially faster than the 3 and 4 to 5 person household. And without addressing this structure change in household, just like what household headship rate method did, and we will have very substantial, more severe errors in the projection. So it's really not about the pros and cons of using Profemi. You invest more of the in the demanding data requirement. It's more about if you do not use Profemi, if you do not address the household size issue in the modeling of household projection, you will have very biased projection in the social economic planning. And now it is part that we get out from the mathematics and the validation. I'd like to briefly talk about how useful the method could be, both practically and academically. And Profemi can be used in many, many scenarios, helping us to understand household transformation, population transition, also help us to do the policy and social economic applications. And that's why Profemi has drawn broad attentions worldwide. Many policy agencies and institutional agencies, they're starting to use Profemi, help with the estimation of the future household changes. I cannot give you all the applications, and then there's a huge literature there. But I want to name 3 of the important applications, which is also the research focus of the Professor Zhang Yi's the Profemi team in the near future. And the first example I want to say, Profemi could be used to estimate elderly care demands. And this is one of the applications in the United States. As we all know that the world is aging very rapidly, and with the aging population, and policymakers would like to know what is the impact of population aging to the society, especially challenge the public health and medical system. And in answering those kind of questions, it is very necessary to know how many old people will be. That's the first issue. But more importantly, we want to know not only how many old people will be, but we want to know how many people need elderly care. And more specifically, how many people are disabled. And therefore, they need investment for the elder care. And Profemi could help to answer these kind of questions. And this is one of the results showing from the year of 2000 and 2050 by two older groups, age 65 and 79, and the oldest old, namely over the age of 80. What will be the number of ADL disabled elderly who are living alone? As you can imagine, these older people, they are disabled. They encounter difficulties in one of the 5 of the most essential daily life tasks, such as eating, bathing, toileting, laundering, and walking. And in this while they encounter those kind of difficulties, and usually we can imagine they will need help. But to make things worse, they are living alone. And this is how many of these people are both disabled, but also living alone in the United States. And you can imagine these people might be the potential target for the government and the community to help. And you can see a huge increase for the oldest old age, as you can see in the United States, particularly the white Hispanic group, And this is another illustration. These are the people who are disabled, but living with their children, not living with their spouse or partner. As you can see, the pattern are quite similar as previous, but the skew actually is larger. Again, we see the oldest old white people increase dramatically. But on the other hand, you can also observe that the Black people and the Hispanic increase dramatically, who are disabled but not live with their spouse, but with their children, increase dramatically. That is different from the previous scenario. And based on the number of how many people are disabled and how their living arrangement could be, we could further estimate the demands of elderly care. And here are the projections of the number of yearly work days of home-based assistance provided to those disabled Americans who are aged 65 to 79. You can see very interestingly, those people, while they are aged 65 and 79, and they are having disability in their daily life, and most of them are coming from the living arrangement of living with spouse. So in this age, young old age, most of them, the demands come from those couples live with their spouse. However, things will be changed when we reach the oldest old age. In this picture, you can see clearly for the females, if in the oldest old age, if they have disability, and most of the yearly work days of assistance should come from the living arrangement of living with children. And probably one of the explanation is many of those females are already widowed. We could also further calculate by the financial payment. This is the total yearly payment for those people who are disabled and who need home-based assistance. You can see for the females and the males living with spouse in the age of 65 to 79, the major yearly payment comes from the family of the older couple. But when they reach the oldest old age, you can see again the females rising up dramatically for the type of living with children, maybe because there's no spouse with them. But on the other hand, we notice that living alone group of those old ladies while they are disabled, there's a huge demands, to pay for the home-based assistance in America. These are very useful applications to understand the future elderly care demands in America. Now let's get back to China, and we are going to talk about another application, which not concerned about the elderly care demands, but more about a very specific domain, namely the housing demands. We can use Perfemi to see how the changes of household structure will affect the housing demands in Hebei province of China. Housing real estate is a big domain, and then real estate developers, for many countries, is a very important sector of economic growth. How to guide this market to better meet the needs of the society. In this procedure, demographic transition should play a critical role. We take Hebei as a province. This is a very typical province in China with a kind of middle development level, a very reasonable size of population, 71 million. And the population, urbanized population is also about 40%. So this is a very typical province of China. And we're using the 2010 census data as the baseline, and also derive the necessary key parameters such as home ownership rate, rental rate, household type, household size, and number of rooms living by different kind of people through the microcensus data, and then apply the Perfemi research method. And here are the results. As you can see, in the near future of China, the most significant increase in the real estate market is really not driven by the young people, getting married and they want to buy a house to start a family life. It's driven actually by the old people. As you can see, the 1 to 2 room owned, 2 to 3 room, the small, small type of, room, apartment, the demands increased dramatically among the older people. And in contrast, young people's demand actually declined or even reduced. And for the middle-aged adults, the demands will increase moderately until after 2025 and gradually reduce. This is very interesting. And when we see even though the household size is becoming smaller in the near future, therefore we also see the increase of 5+ room housing unit. And in this market, you still see the consistent increase coming from the older people. And this is owned house unit. In the housing market, we also analyze the renting house unit. As you can see, this is a quite similar pattern, but as you can see, it's not as large and dynamic as the owned housing market. We could also analyze by different room types to see what kind of family are living in those rooms and are driving the demands. And very interestingly, you can see the 1-person household, the 1-couple household, and also the single parents and their children. These 3 types of household, their demands for housing are increased dramatically and consistently. On the other hand, the traditional 3-generation household kind of decrease by year. And also the typical nuclear family, like the 2 parents plus the children, and indicated by the blue line, will increase gradually, but at the year of 2025, after that year, you can see the demands reduced. These are very important information, both for the real estate developers and also for the local government. But to be honest, these are also important intelligence for many industries. For example, air conditioning industry, refrigerator, and television, because you can simply imagine each of these housing unit will come with the consumption of the durable commodities, and we could easily and straightforwardly link those results to the future commodity market. And we also project by rural and urban. And as you expect, with the rapid urbanization of China, most of the demands for the housing, comes from the urban area, and then the rural demands is declining. It's declining. And we also measure the renting market. And now, people also are interested in the total number by age. Like I don't want to differentiate by different room types. Tell me the total number. Yeah, we can see like as compared to the year of 2010, housing demands for the elderly increased dramatically, like 2 times to 4 times. But the housing demand for young people less than the age of 35 actually reduced dramatically. On the other hand, what kind of household is behind those housing demands? As compared to 2010, the housing demand for 1 person, and a single parents and children household will largely increase, but the 3-generation household will substantially reduced. Okay, here's a very general summary of about this application. We can see demands of housing for older people will grow dramatically. That will have a very important message for the government and to develop housing for the older people. I believe it's not only about developing the housing for the older people. It's also about how to develop better living environment for the elderly people. While I believe many experience in Singapore could be learned by China and many countries in this regard. Namely, while you develop housing facilities and infrastructure for the older people, it's always needed to give some very aging-friendly facilities. For example, in the bathroom, maybe you could install a bar, helping elderly people to stand up after toileting, and also install some of the bars, in the corridor for the elderly people to walk. So the policy implication will be very rich. But going back to Profemi, it is Profemi illustrate what's going on in the near future of China of this huge demand of elderly housing. And also we can see a very significant growth in a 1-person household, and also 1 couple household without children. Okay. Now let's talk about the very last example applications. We want to talk about we talk about application for the elderly care demands. We talk about the elderly housing demands. And now let's talk about a little bit on the energy demands, how Profemi could help in pushing research in this field. As you can see in China, the increase of household is faster than the increase of population. Clearly, the conclusion will be if you use population as the base to get average person's energy consumption and to derive the future energy consumption. And you will get very biased result. And because the number of households actually increase much faster. So the Chinese household is getting smaller due to multiple reasons. Many young people are migrating from rural to urban, and adult children may not choose to live with their older parents. Divorce rate has been keep increasing, and also population aging is rapid. Many elderly people may no longer or live with their spouse or just living alone. This kind of demographic and social economic trends make household size smaller. And the implication will be very huge in the energy and resource consumption. As you can see, based on the projection of Profemi on the Hebei province, you can see the energy, the water, and fuel will always increase from the year of 2010 to 2050. And what's behind this is the household change. This is a decomposition of those energy and resource consumptions by different household size. As you can see, most of the increase of the consumption in electricity, water, and fuel will come from small size household. And for the larger size household, actually, it is actually decreasing. And by rural and urban, due to the rapid urbanization in China, most of the energy consumption will be concentrated in the urban area. And for the rural area, for the water and fuel, the consumption are actually reduced. And by population age structure, you can see older adults older adults and their families actually will be the major forces driven the energy consumption. And that is a very impressive message and telling the future governments to be prepared for this. Like most of the resources and the energies will be consumed by the older elderly household. I briefly introduce some of the major applications, and here are the recent plans of the professor teams under the leadership of Professor Zhang Yi. Profemi is making very substantial progress in the recent few years. The first progress is Profemi is going to be updated from the deterministic projection to the probabilistic household projection, the PHP model. And correspondingly, the software will also be updated. And empirically, we would like to organize an international team from the major developing society, including Singapore, to conduct Profemi applications to check about living arrangement, household, and housing issues. And we are going to, by the end of this year, we are going to have a conference, and you are all welcome to join us. And hopefully we could start the research as soon as possible. And all these research activities has been strongly supported by the United Nations Population Division. As you all know, the UNPD has the world-renowned World Population Prospect, but do not have the projection on household. And we all believe and think that Profemi will be one of the strongest candidates to contribute to the United Nations in regard to the household projection. Thank you very much. On behalf of Professor Zeng Yi, I thank for your listening. And now, question and comments. Thank you. Okay. Sorry, I'm the as the moderator. Let me raise the questions for Professor Wang. There's a question from Jiwei. Jiwei is our colleague from East Asia Institute. Thank you for your question, Jiwei. Jiwei asked Professor Wang Zhenglian for the Profemi method, whether there are variations in predicting population dynamics in big city and small city. In big city, there might have been more complex social interactions. And there's also the law of large numbers. So how can we differentiate large city and small city? Yeah, Professor Wang, yeah.
Yeah, it's a good question. Actually, our model, as I report, we can do the national and the subnational. But for the small city, small area, actually, we could not directly apply the model. We use, very popular, famous regional method. The method like that. First of all, you do the big city or big province, the household and population projections. And then you can use the sensor data and know the ratio of the between the households, by household size, household type, and so on. And actually use the ratio method to estimate the small areas, small cities, households projections. And regarding how good or how bad of the result in comparison with the big city, we did the validation as well. And we have done the small area like North Carolina Triangle area. And we use the same method, and we did, using 1990s data and project to 2000, and for the triangle areas, population, and the households. And we didn't see the significant difference, regarding the variation between large city and a small city. Yeah. I don't know if I answered your question. Thank you.
Thank you, Professor Wang. I see. I see another question from Nanxun. Nanxun is our PhD student from Department of Sociology. Okay, Nanxun said, I have a question. As you mentioned, the elderly people will have increasing demands for the 3 to 4 rooms household. There also a decline in the 3 general household. So I'm wondering who will be living with those elderly people in a larger household. Will the relatives of the elderly living together for elderly care? Yeah. Professor Wang, can you answer this? Yeah.
Yes, for the housing, they did is for the Hebei application, and Hebei is like the area they have like 0.5% is urban area, 0.5% is rural area, and for the increasing of this elderly households demand for the large family size is mainly from the rural area. And even though in general, the 3 generations households is decline, but because the timing and other covariance, and what we found the third generation household in the rural area in the short time will increase. That's because, and you know, in the rural area, and the fertility, the decline is not as fast as urban area.
Thank you, Professor Wang. Actually, in line with Nanshu's question, I would like to respond a little bit more and also seek input from Professor Wang. The issue is in regard to elderly living arrangement. Living with a household is definitely one of the major preference. But another option is institution, living in institution. And Profemi has made a methodological breakthrough to project the future increase of institutions. So that's very important. I think that's not only important for the household, but also it has the market value, because how to take care of older Chinese, definitely Yang Lao Yuan, the older care institution, will start to be a major solution. And I would like to ask Professor Wang to say a bit more about the projections on the institutions.
Yeah. So the one of advantage of Profemi model, we are not only project and analysis and forecast the household and the family. And because our model, we deal with entire population. So that in addition, we have you know, the outcome of number of households by type and size and so on. And we also can forecast the institutional population. That's important for most countries, especially developed country. It is a new phenomenon. And based on our analysis, actually, and the demand for the institution is increased dramatically, so that our model and have the forecast a result for this institutional population. So what we did, so we not only treat, so as I said, we treat everyone as equal, and our analysis unit is individual, not like other micro models, is a household. But for the individual, actually, we identify the individual by family and no family. So in this case, we can ignore if there's sampling trouble with you know, proportion of institutional population, so that we already overcome some kind of sampling trouble. So if you sample, if your macro data not representative, the whole population, and our model can help you correct this. And recently, I have a study collaborate with Professor Feng, and we have very good result to analyze Chinese institutional population. We can see that in the future, no matter people like or don't like, that is a phenomenon, because people are aging, and for the oldest old fertility, and when they cannot be able to independently live in the household, this has to be the next step. Yeah.
Thank you, Professor Wang. I actually see in our audience, there are many of the young students. So I asked a question to you on behalf of them. Namely, Profemi a method has been developed, for a few decades, and for the users' perspective, sometimes people may feel like being confused about how to prepare the data, particularly in preparing for the data, the scheduled data in terms of marital transaction rates are not so very available for many researchers. I do realize that Professor Zeng and Professor Wang are developing a secondary software called the demo rates in order to estimate those key parameters for the Profemi users. Would you please say a few more words about this new progress?
Yeah, thank you so much for Professor Feng to mention this. This is recently our big progress of improvement of tool and software and for user to apply Profemi model. Yeah, as I said, Profemi model is good, and we can link with numerical rates. So that in comparison with hardship rate, we do demand so many data requirement. One part is standard schedules. For mortality, normally is available. The life table everywhere in every country, from a statistical bureau, but the reality is that for the marital status transition rates, is normally people cannot directly get this transition rate, so that we have to use service data to estimate this transition rates. This is a huge labor work, not huge labor work, and also required your statistics technique and demographic knowledge. So right now we have we develop R package so that you can use our package and easily to have all the transition rate, all the standard schedules can produced by demo rates. Actually, you only need to reorganize your survey data. For example, you have the survey data with a questionable variable, questionnaire variable. And then you just transfer this data format, data set, to the demo rates format. And then you apply to the demo rates our program. Then you get the already smooth marital status transition rates, fertility rates, migration rates, and the children leaving home. And behind this demo rates method, we use Gaussian regression method. And we already text to US data and the Chinese data and survey data and census data. And the results is reliable, it's good, and it's really useful too. Thank you.
Thank you very much. And I see we have no more questions, and I hope like the audience has learned a lot about this method. Thank you very much, particularly our very best wishes to the health of Professor Zhang Yi. And so let me end this the session now. And again, thank you very much for all the audience and for our great speakers. Thank you. Yeah. Bye-bye.
Thank you very much. Thank you.
Yeah.
Bye.